Okay, write the equation of a tangent line where t equals to 2, where the vector that represent the time equals to 2. We write the equation of the tangent line by first finding the slope at t equals to 2. We start by looking at the derivative of the position vector, which is going to be 6t squared minus 6t. That's the component, that's the x component. And then the for the y component, it will be 3t squared minus 12. Remember that vectors can be written in many different ways, okay? So I just decided to write this in vector form. And then I took the derivative instead of writing in the ij form. So I took the derivative of this, that's how I got that. So I want the slope at t equals to 2, right? So the slope, which means that I need to right there replace 2 in here. Okay, what do I get? Well, I'm gonna get 6 times 4 is 24. 24 minus 12, which is gonna be 12. And if I replace 2 in there, I'm gonna get 12. 12 minus 12 is really 0. Okay, so this is the velocity, right? The velocity at 2, which is 12 comma 0. In other words, the change in the y direction is 0, and the change in the x direction is 12 at 2. So when we talk about the slope, we're talking about like rise over run. So the change in y over the change in x, and that's equal to 0, and that's the slope, right? Slope is the change in y over the change in x. The change in y is 0. The change in x is 12. So 0 over 12 is 0. So that's the slope. Slope is a number. Remember that. So we found the slope of that vector. And the second thing is we need to find the point at t equals to 2. So I'm running a little short on room here. So I'm going to kind of draw this bar. I'll continue my work in red. I am going to find the point, which means that you evaluate r at 2. And if you evaluate r at 2, here's r, or here's r. If you evaluate r at 2, you are going to get 8 times 2 is 16. 16 minus 12 is going to be 4. 8 minus 24. 8 minus 24 is going to be negative 16. That would be my point. And so I will now use y minus y1 equals to m times x minus x1 to come up with the equation of a line. Y minus, my y1 would be negative 16. So that would be a plus 16. Lucky for us, our slope is 0, and then I have x minus 4, okay? But 0 times, the right side is going to be 0 here. So the equation of the line is going to be a horizontal line, which is y equals to negative 16. So that's the equation of the tangent line. Find the coordinates of each point on the path where the horizontal component of the velocity is 0. So they want us to find the coordinates, which is like the x coordinates, the x value, where the horizontal component of the velocity is 0. All right. If you look at the first derivative, this is the velocity vector. This guy right here is the horizontal component, and we want to know when the horizontal component equals to 0. So from what we found, we know that x prime, which is the horizontal, the slope, the velocity of the horizontal component, it's 6t squared minus 6t. That's the horizontal component, okay? And we want to know where the velocity equals to 0. So we replace 0 for that, the velocity of the horizontal component, and then we determine the time. Fact out is 6. So it happens at 2 possible points, or 2 possible time, t equals to 0 and t equals to 1. Now the question is find the coordinates, not the time. That's not what they want us to find. They want us to find the coordinates. So once we have found the time, we plug these into the original position to find the coordinates. So if I replace time equals to 0 in there, then one of my answer would be like 0, comma 0, okay? And if I replace 1 in there, then my answer would be 2 minus 3, which is -1. And then if I replace 1 in there, I would get 1 minus 12, which is going to be -11. So those are the coordinates. That's what they asked us to do. So we did. We found the coordinates. Okay, pretty tricky problem right there. Find the coordinates, which is not the time. So you got to plug them back into the original function, the original position vector, to find the coordinates. All right. Very good. All right. So integration. Integrating vector is really simple. It's the same as integrating a function. Notice that a vector can be written as a linear combination. So when we integrate a vector, we integrate its component. That's the only thing we can do. So this equals to the integral of x of t I with respect to dt plus the integral of y sub t j with respect to dt. This is indefinite integral. Definite integral, same business, just the fact that we have an upper and a lower bound. X sub t of I dt plus ab y sub t of j dt. Now in practice you would leave out the I and the j when you integrate, but once you're done then you bring that back in. Okay, so you would really leave it out, but when you're done you bring it back in. Alright, let me take you through a last example, example number 6. The velocity vector is given by this guy, I and j. Notice that there's an I and there's j. It's a linear combination. So what I like to do is I like to always kind of write it in its vector form, which is minus 3t squared minus 8t minus 4, and then 2t to the third. Remember that this is the velocity, and velocity is related to r prime. Okay, that's velocity. When t equals to 2, the position vector is 4, 8. So at t equals to 2, okay, r of 2 equals to 4 and 8. So that's position. Remember, positions are, okay. Find the equation for the position vector. In other words, they want us to find r of t. What is the position vector? What is r sub t? That's what they want us to find. Okay, so it does involve some work for this problem. In order to find r sub t, we have to find the x component first, find the y component next, and then kind of put them together. So here's what we know. We know that the x component can be found by integrating the derivative of the derivative of the velocity, just the x component of the derivative of the x component. Okay, so from looking at what we have over here, this is x prime, -3 t squared minus 8 t minus 4 dt. Okay, that equals to minus t to the third minus 4t squared minus 4t plus c. Okay, because that's indefinite integral, you got to add c. So use the given condition, which is at time 2, x sub 2 equals to 4. Right here at time 2, this is x sub 2. Okay, x sub 2, because r of 2 is really x of 2 and y of 2, and we know that's equal to 4. So I'm going to replace 4 into here, replace 4 in here, replace 2 in there, and solve for t. So replace 4 in there, and then replace 2 in for this. That gives me -8 minus, that also gives me 8. This gives me negative, oh, I'm sorry, that should give me 16. My mistake, 16. That would also give me 8 plus c. So all together, what do I have? I have 16, 24, 32, -32. So c equals to 36. C equals 36. So I have x sub t. X sub t is equal to minus t cubed minus 4t squared minus 4t plus 36, because I found that's 36 over here. Okay, I found c is 36, so that's 36 using this condition. I found x sub t. Now I gotta go and find y sub t. Y sub t equals to the integral of the first derivative dt. Okay, so this represents antiderivative. Plugging in what this is, 2t to the third dt, taking the antiderivative of that, we get 1/2 t to the fourth plus c. Initial condition is 8. So 8, it's 8 when t equals to 2. Solving for c, we get 16, so that's 8. So c equals to 0. How nice. So y sub t equals to 1 over 2t to the fourth. So putting everything together, the position vector, I'm going to answer it over here, is equal to, this is your x component, minus t cubed minus 4t squared minus 4t plus 36, comma, 1/2 t to the fourth. Okay. Very good. I will see you guys on Thursday.